All right, folks, welcome to lesson 17. And here we're talking about confidence intervals where we don't know the standard deviation of the population, a very common situation. How are we going to be able to resolve questions like this? I'm glad you asked that question. Let me find an answer. Take a moment and read this question and see if we can get our minds around it. Okay, we're talking about the judicial system and waiting around for our court appointment. Well, let's see. What do we have? We have 8 people. No, we have randomly surveyed 81 people. 81 people, and the mean of the 81 is 8 hours waiting for their appointment. Okay. Of course, we're supposed to have a speedy trial. That's another conversation for another day. Now, the standard deviation, big S, of that is 4 hours. We want to know with 95% confidence what actually is the population mean. What is the average wait time? Good question. How are we going to do it? We do not know the population standard deviation. All right, a couple things while we're waiting for an answer to that question. Remember your task list all the way through here for this particular unit, okay? And we'll end with some advice for your quiz. All right, so what we have here is these are the general notes of listening to the lecture, watching the example videos, doing the exercises. What can I boil down the whole notes to? And here they are right here. Okay, let's just point out a couple things. Of course, what we're doing is we're talking about the properties of a t-distribution. More often, we don't know the standard deviation, so we use S. But the only problem with this is we cannot use z-scores. That's not a good thing. And all of the distributions for a student, for a for a type of problem like this are all different. That doesn't make a lot of sense. It doesn't help us. Now, the degrees of freedom for this lesson is n minus 1. Degrees of freedom. If you want more about that, there's more that could be given. I don't want to get too deep into that right now. Well, what about this distribution? It's symmetric, but it has more spread than a standard normal distribution. And the higher the degrees of freedom, the closer it is to a normal distribution. I'll show you a picture with that if you need to. A couple assumptions that we're talking about. Let's assume that we had a simple random sample. That's important. And now notice this or here. Either we have n is greater than 30 or we know that the population is normally distributed. Now, those are good questions we need to be able to answer. So that takes care of the assumptions. Now, we're going to need to know the critical value. Well, the critical value is going to work a lot like the sigma known type problem, but we're going to use what's called the t-table. And we'll talk about that table in a second. Let's talk about the steps to solve problems like this. This is an important part. First of all, get the mean and the standard deviation, use your degrees of freedom, go to the table, find your critical value, then find your margin of error. Notice this is the same way. Use that information to find your confidence interval. You're going to use the mean and your margin of error to do it, and then interpret it, okay? Be able to explain it in plain words so that Joe on the street can understand it. This, my friend, is the gist of the notes. Now, I'm going to show you just a couple pieces of the slides. This slide helped you to understand that, hey, we really, because this is not related to a normal distribution, we can't use z-scores. We'll have to come up with another way to find the critical values. Now here's why. Notice I have a standard normal curve in the background, and by the way, we could thank William Gossett. He actually worked for a brewery, and he spent a lot of time on this, and he figured this out. So I just wanted you to bear with that here, okay? All right, anyway, make a long story short. So this is a curve for degrees of freedom being 1. Now, the problem with this is, you know, these z-scores we would use to find percent of data, they don't work with a curve like that. So again, that's why we have a little trouble. Matter of fact, they're wider, okay? But the closer, the higher the number, the n, the closer it gets to a standard normal. And that's what this visual aid is supposed to help you with. Okay, so now I just kind of cut to the chase. Here's the actual table, okay? The actual table. So let's just say you wanted a, let's say you wanted a 90% confidence level. That would be 5 on each end, right? 5 on each end, just like the Z one. So we're going to use, we're going to go over here, and that would be, the tail would be 0.05. And let's just say you had n is 10. N is 10. Okay, you use degrees of freedom to go down to 9, and you look on the chart, let's just say, in here, the value would be 1.83. That would be your critical value, okay? But notice on this chart that the further you go down, the closer the numbers get to what? The Z number. Okay, remember that 1.645? So hopefully this chart makes sense to you. And it has to do with not knowing the standard deviation of the population. Hope that made sense. Okay, again, this is an example in your notes. And so here we're trying to find the 95%. So we're in the right column here. And there's our critical value. Very, very important. Okay, now we're ready to go back to our problem. Okay. Well, we remember that n is 81. And remember that the sample mean, we're doing a sample of people and their wait time, that was 8 hours. Okay. What else do we know? That the sample standard deviation is 4 hours. Okay. Find a 95% confidence interval. All right, so the first thing we're going to do is get our facts. Well, we do. We have all of the facts right here, okay? Second thing we're going to do is try to find the confidence level for 95%. 95%. How are we going to do that? Okay, here's our chart. Now, 81 is close to 80, and then here I've got 95% would be right here. You could kind of cheat down here if you wanted to. So 1.99 is our critical value. Okay, let's get into the nuts and the bolts of doing this problem. There's our 1.99, okay? So x bar plus or minus the margin of error. Here's our critical value, standard error of the mean. Critical value we know is 1.99, standard error of the mean. We're going to use this formula, okay? And we're going to get 4/9. So what does this mean? No pun intended. 8 hours plus or minus 1.99 times what? 4/9, okay? So we're going to put that in the calculator. All right, so I did 8 minus that, and I got 7.12. 7.12. I did 8 plus that, I got 8.88, okay? So this is our confidence interval. Can we interpret it? We are not, with 95% confidence, we could say that the average wait time for someone waiting at court is 7.12 hours to 8.88 hours, okay? And that may be important information. Okay, here's a little graphic on how to do that on the calculator. Don't forget you're looking for this t interval and you're using statistics, okay? And here's the data. Okay, so here you go. Remember, you're going to go to distribution and you're going to go all the way down there to the bottom. Okay, I just messed up. You're going to hit stat and you're going to go to not calc but tests, and you're going to go down to the bottom. So it's below the 7. I'm just going to hit 8. Okay, now I'm ready to put in my data. Okay, don't forget we're doing stats. Okay, there's our x bar, standard deviation, the number, confidence level. Okay, we're going to hit enter. And lo and behold, we're going to do this calculation. Remember, we said 7.12. That does round out 8.88, and that does show also. So now I know that you're saying, do I need to know the table? Do I need to know the chart? Do I need to know everything about the student distribution, t-distribution? The answer is really yes, okay? But for your test and to get through the rest of the course, you don't. You need to know how to do it on your calculator. Make sure that you do. I wanted to give you another example of this particular lesson, number 17, and where we have data. So here we go. We have 6 different national brands of chocolate chip cookies are randomly selected at the supermarket. Yay. The grams of fat per serving are as follows. So 1, 2, 3, 4, 5, 6. We only have 6 pieces of information, folks, okay? And now the question is, we could, put that in our calculator and we can find the mean and the sample standard deviation. We could do that, okay? But another way to do that is to use the power of your calculator. And the way we do that is we put the data in L1 and then we go through the procedure. So again, what are we looking for? Assuming the underlying distribution is what? Approximately normal. Find a 90th percent confidence interval for the population mean of grams of fat, okay, with the chocolate chips at the supermarkets. Let's see if we could do that. Okay, folks, got the data in L1. Now I'm going to go in to Stat, Calc. Remember, we're looking for 8, okay, a t interval. And now we're going to go and select Data. Here, my information is in L1. I'm not going to worry about the frequency here. Okay, and remember, we wanted 0.90 confidence, okay? So, hey. Okay. So here is the correct answer, rounded to 2 decimal places, 7.64 and 9.36. We are 90% sure that the mean fat calorie weight for these cookies in the supermarket is blah, okay? So hopefully you enjoy that. Again, I would write that out, okay? You don't have to do that on your test though, okay? And there's the data and the results posted up there as well. I hope this helps you with doing a couple problems in this lesson. Don't forget, folks, the resources that are available for you. There are a lot of things out there for you by way of resources. You're only limited by your time, your interest, and your ability to focus. But try to maybe enjoy learning, because this is a very pervasive thing in our culture, and it really does give you insight into really a lot of things. So I made these videos here that are hopefully they're helping you understand how to get into the content and how to work the problems, okay? It's kind of like that story, you could lead a horse to water but you can't make him drink, but I am really trying to make you very, very thirsty, okay? I hope that makes sense. Don't forget your tutor, your smart thinking, the gazillion videos on YouTube. You got each other, and of course you got me. All right? So take advantage of those opportunities, but don't take advantage of me, all right? And I hope that helps you. Okay, oh, excuse me. I've been studying the quiz related to this particular lesson, and I have to say, I enjoyed taking it, but it was kind of brutal in a couple places. So my advice to you is make sure that you know the lesson, exercise questions, go over it, use my little keys if you want to. And here's my advice. You can use a z-interval if n is less than 30, only if the data is what? Normally distributed. Hey, I hope that helps you. Best wishes in lesson 17. Take care.